In this video, I want to define the addition rule for probability. And to start with, I'm going to have to define mutually exclusive. Mutually exclusive events are events that have no elements in common. As an example, if we're drawing from a deck of cards, drawing an ace or a king, there is nothing in common. There is no single card that is both an ace and a king. Something that is not mutually exclusive, drawing a heart or a king, since there is a card that is both a king and a heart, so they do have something in common. I now want to define the addition rule for probability. The probability of A or B is the probability of A plus the probability of B minus the probability of them happening at the same time, probability of A and B. And if A and B are mutually exclusive, this means that the probability of A and B is equal to 0, so I get to ignore that last term. Let's look at some examples of this. Let's suppose we draw a card from a standard deck of cards. I want to know the probability that we draw a king or a diamond. The addition rule says we start with just the probability of drawing a king. There are 4 kings in the deck out of a total of 52 cards. We then add the probability of a diamond. There are 13 diamonds out of a total of 52 cards. And then we subtract the chance of getting both. There is 1 king of diamonds out of 52. So when I add these up, I get 16 out of 52. Next, let's look at the probability of drawing a 4 or a king. There are 4 4s in a deck of 52 and 4 kings. And these are mutually exclusive events. They do not share anything in common, so I don't need to subtract anything out. And we just have 8 out of 52. Next, I want to look at the chance of drawing a face card or a club. There are 12 face cards in a deck. We have a jack, a queen, and a king, and 4 of each of those. There are 13 clubs in a deck. And then we need to subtract out the ones that they share. There is a jack, queen, and a king of clubs, so they share 3 out of 52. So once we add these up, we would have 22 out of 52. In a class of 30 students, 16 study French and 21 study Spanish. And all students in this class study a language. I'm going to randomly pick a student, and I want to know the probability that they study French. Well, we know that there are 16 students that study French out of 30 students. Next, let's look at the probability that they study both French and Spanish. We don't have a set rule for this, but we can think it through. There are 16 that study French and 21 that study Spanish. That gives me a total of 37 students. However, we only have 30, which tells me that 7 have to study both. So we have 7 out of 30. Finally, I want to know the probability that they study either French or Spanish. We know the chance they study French is 16 out of 30. We need the chance they study Spanish. That's 21 out of 30, since there are 21 that study Spanish. Minus the chance that they study both, which we just found to be 7 over 30. And when we simplify this, we get 30 over 30, or 1, which does make sense. We said that all students in this class study a language, so we have a 100% probability that they study one of our languages.